Welcome to Honors Pre-Calculus 1.1 Lines in the Plane. Welcome to anybody else who happens to be viewing this, including my students in A2 PC. I believe that this is a section that should be review, and even if it's not review at the level student that we have in these classes, this should be something we should catch on to pretty quickly. I believe we should know that slope of a line is the change of y over change of x. We subtract the y's. We often call that rise over run. How much do we go up as we run to the right? Sometimes we go down, we have a negative slope. One thing to note about this, if I was to take this slope m, put that over 1, cross multiply that, I would get y2 minus y1, I'd get y2 minus y1 times 1 equals slope times x2 minus x1, and we virtually have our point slope formula, something you might not have made a connection with before. Things we should know about slope at this time: if a line has positive slope, it is rising from left to right, for instance like this. A line negative slope falls from left to right. A line with slope of 0 is horizontal, and a line with undefined slope, how do we get an undefined slope? Well, if let's say I find the slope formula and I get 3 over 0, that's undefined, which means from a point on the graph we'd rise 3 and we'd run none. So there's undefined. Okay, point slope form, we just mentioned. I would think everyone's seen slope intercept form. Here's some other forms. We're going to primarily focus on slope intercept form and point slope form. Of course, we'll have vertical and horizontal lines as well. General, we won't see quite as often. Two lines are parallel if their slopes are equal, and they are perpendicular if they are opposite reciprocals. In other words, y equals 2/3 x minus 3, which has slope 2/3, would be perpendicular to y equals negative 3/2 x, say, plus anything, 4. They're reciprocals and opposite signs. Okay, let's go ahead and get started in the example. We're going to go through these fairly quickly, but you can review them. They will be available. In exercise 7 and 8, identify the line that has the indicated slope. Line with slope 0. My choice is line 1, line 2, line 3. I guess line 2 down here. The only one that is flat, not either increasing or decreasing, is line 2. Line with slopes that are negative have to be going down from left to right. So from here to here I go down and right. Or from here to here I go up and left to get on the line. That would be equivalent to saying I go up 3 and left 4. So that is line 2. And slope of 1, or rise 1, run 1, is up and right, or down and left. In other words, this could be negative 1 on negative 1, where I go down and left. But anyway, from left to right, it's increasing. So this is line 3. One of these I listed wrong. This is line 1. Okay, let's zoom in just a little bit here. Make it a little easier on your eyes. Exercise 13 through 16. Okay, this is a good time for me to kind of talk about the homework philosophies in this class based on instructions. Unless I specify differently, a lot of the problems in your assignments are going to have do something algebraically and then check it with your graphing calculator or something along that line. Typically what I want is the first way they've phrased the question. Okay, in 13 through 16, find the slope of the line passing through the pair of points, then use a graphing calculator to plot the points and use the draw feature to draw a line segment. So we're just going to find the slope of this line. And our slope of the line is change of y over change of x. A lot of times we'll write that as delta. That's change of y over change of x. If you haven't used that little delta symbol, it's coming soon in calculus. You'll be seeing it all the time. So I always draw the lines. I change the y's, negative 4 minus 4, over change the x's, 4 minus 2. Worth noting, I could do this 4 minus negative 4 over 2 minus 4 in that order. But you can't shift orders. I can't go 4 minus negative 4 left to right, and then 4 minus 2 right to left. So this gives us negative 8 on 2, so the slope is negative 4. Easy enough. Okay, sketch the lines through the point. So we have a point, negative 4, 1, with the indicated, through the point with the indicated slopes on the same axis as we have. So slope of 4, I like it as a fraction. That means I'd like to rise 4 and move to the right 1. 1, 2, 3, 4, and 1. Or fall 4, because this could be negative 4 on negative 1. 1, 2, 3, 4, run to the left 1. 1, 2, 3, 4, run to the left 1. Don't have a straight edge handy, so I'm just going to keep it as neat as I can. And that would be, I'll label that one A. B also passes through this point, has a slope of negative 2 or negative 2 over 1, which means it wants to fall 2 and go to the right 1. Fall 2, right 1, fall 2, right 1, fall 2, right 1. Or rise 2, excuse me, in the wrong spot. Or rise 2, run negative 1. Come back to that. Rise 2, run negative 1, up to 1 to the left. So that is our line B. Line C rises 1, runs 2, up 1 over 2, or falls 1, runs 1 to the left. Something like this, where there's our line C. Now lines that are undefined run straight up and down. The slope is so big we can't define it with a number. So through this point, straight up and down would look like that. There's our line D. Versus if we had a slope E of 0, we would be flat or horizontal. Okay. Use the point on the line and the slope of the line to find 3 additional points which the line passes. And your first thought might be, let's draw a graph. And you're welcome to do that. But if the slope is 0, I could write that as 0 over 1. That's my change of y over change of x. So that means y increases by 0 when x increases by 1. So my y value increases by 0 when my x value increases by 1. My y value increases by 0 when my x value increases by 1. And my y value increases by 0 as my x value increases by 1. And that's why they say there are many correct answers. In fact, many is quite an understatement. Okay, m is undefined. If I have a slope undefined, the denominator's 0. So I'm going to call this 1 over 0. Therefore, my x increases, or excuse me, my y increases by 1 when my x increases by 0. My y increases by 1 when my x increases by 0. And my yes, I got that right. And my y increases by 1 when my x increases by 0. And you could have just as easily made this be negative 3 on 0 and have your y's decrease by 3 when your x's increase by 0. Okay, and finally, here's my change of y over change of x. This is delta y, delta x. I'm going to write it as negative 1 on 3. Again, you could make that 1 on negative 3. I'm going to make it negative 1 on 3. Get my mouse out of the way here. A little bit of room. So what happens? My y's decrease by 1 as my x's increase by 3. My y's decrease by 1 to -8 as my x's increase by 3 to 5. And my y could decrease by 1 to -9 as my x increases by 3 to 8. Okay. 28 through 32. Exercise 25 to 32. Find an equation of the line that passes through the given point and has the indicated slope. Now, here's a biggie for you. There's going to be times I'm going to ask for just an equation of a line. You don't always have to put it in slope-intercept form. Some of you are in that habit. That's a big time waster when you get into the AP exam in calculus, because oftentimes you're just asked for an equation of a line. And if we want an equation of a line with a given slope, and I've got point slope, I'm going to use point slope form. And real quickly, point slope form is y minus the y coordinate equals m times x minus the x coordinate. Those are just the puzzle pieces I need to come up with an equation. Everything else stays the same. Y minus stays the same, parentheses, x minus stays the same. So this becomes, I'll rewrite it here, y minus the y coordinate equals slope times x minus the x coordinate. So it's y minus the y coordinate equals slope times x minus the x coordinate. And you might have done this in just one step. Recognize that's y plus 5 equals 3/4 times x plus 2. Now, special cases. When we are undefined, our line goes straight up and down. In this case, we're over at, say, -10, 4. And our line looks like this. And people will make mistakes on this. Generally, what I see is people will know by the time they're in this course, they know that when the slope's undefined or when the slope's 0, it's either just plain old y equals a number or x equals a number. Well, and people will see this, they'll say, well, the y's are, since it's going up and down, it must be a y equals. No, because it's always left 10. Every point is always left 10. It's the x value that's fixed. X is right and left. Like this is -10, 0, -10, 4, -10, 5, -10, 6. No matter where I go, x is -10. When the slope is 0, at 2.3, let's say down here, looks like this. The y's are always -8.5. Y is -8.5. We're always down 8.5. All right, let's take a look. Problems 35 through 42. Determine the slope and y-intercept. To do that, I'm going to use slope-intercept form, which you're probably most familiar with, y equals mx plus b. And I'll often say slope-intercept, slope starts with s, you can make s stand for solve for y. So I'm going to solve for y. I'm going to leave -3y. I'm going to subtract 4x on both sides. I'm going to add 9 to both sides. And then I need to divide both sides, the entire side, by -3. And I get y is 4/3 x minus 3, making my slope 4/3 and my y-intercept -3. Now, to describe the graph, I probably would just say it's a line that has a slope of 4/3 and a y-intercept of -3. So once again, this is when they're asking a second part of the equation, unless it's like an A, B, C kind of problem, then I'm just interested in the first question. Let's see, we'll go to 50 first. Finding the slope-intercept form. So I need a slope, I need an intercept. I'm going to go for the slope first. You could probably suggest the y-intercept's 1, but I want to talk about that in just a moment. So my slope could go from, change the y's, 3/2 minus -1, change the x's, -1 minus 4. And that is 3/2 plus 2/2, 5/2 over -5, which could be 5/2 times, you know this, -1/5. Cancel the 5's, I get -1/2. So our slope is -1/2. this appears as though the y-intercept is 1. However, what if it's 0.999 or 1.002 or something like that? Well, if my slope is negative 1 on 2, I would go down 1 over 2 or down 1/2 over 1. So sure enough, the y-intercept is 1, and our equation is y equals negative 1/2 x plus 1. Probably the most common mistake here would be to miss the negative, even though if I asked is the slope of this line positive or negative, you would immediately know it's negative as it's going down. Okay, you're going to write small here. If you're taking notes on this, write an equation of the line that passes through the points. Use slope-intercept form if possible. So we're going to try to go into slope-intercept form when we can. To get an equation of a line, almost always I'm going to go into point-slope form unless they give me the y-intercept to begin with. Point-slope form, I need a slope, and either way, I need a slope. So my slope, I'm going to go this way. It doesn't matter which direction so long as we're consistent. 3 minus negative 4 plus 4 on 4 minus negative plus 4, I get 7/8. So there is our slope of this line, which isn't going to be the most friendly to deal with. So I'm going to use the first point, y minus the y coordinate equals slope 7/8 times x minus the x coordinate. And I want to go into slope-intercept form. If I only asked for an equation of a line, you would be done. So this is going to be y equals, I'll deal with the 3 in a little bit, 7/8 x plus times minus minus 7 on 8 times 4 on 1, the 4 and 8 reduced to 2, 7 on 2, and I have to add 3 to the other side, plus 3. 6 on 2, of course, being 3. And I get y equals 7/8 x minus 1/2. Okay, 54 now. If we're just trained algebra chimps, which I'll talk about quite a bit, up until now we probably have some algebra skills, but maybe we don't take too much time and think because it's just become shoe tying for us, or it's just a routine. We would do something like this. Y equals, change the y, 6 minus 6 over, change the x's, negative 1 minus 5, and we get 0 on negative 6, and we see that our slope is 0. So when our slope is 0, hopefully we know at least this. Hopefully we know that it's at least a y equals plain old number or an x equals plain old number. Now, is it vertical? Is it horizontal? Had we not been trained algebra chimps and we looked right at the beginning and we said, you know what, this value is never changing. No matter where I go on this line, the y value is going to equal 6. There's our equation. Y equals 6. Let's take a look and see if that makes sense. Slope is 0. We're going through negative 1, 6, and we're going through 5, 6. Yep, the slope is 0, and all the points are up 6. Okay, 58, just maybe a little bit messier just because we got a lot of fractions to deal with here. And I don't have any problem with you setting this up and using your fractional calculator. Even on an AP exam, this would probably be on a calculator portion, but we're going to go through this by hand. Slope. I've got 3/2 minus 7/4. I'm going to make that 6/4 minus 7/4 over, now my least common denominator, 4 and 3, is 12. So times 3 on 3, 9/12 minus negative, to get a denominator of 12 here, times 4 on 4, 16/12, gives me a slope of negative 1/4 over, let's get my computer screen back here real quickly, hopefully. All right, negative 1/4 over 25/12. And that could be slope equals negative 1/4 times 12 on 25 reduces to 1 and 3, or negative 3 on 25. Giving me an equation of negative 3 on 25 is my slope, and I'm going to use this point. Y minus the y coordinate, 3/2, equals negative 3 on 25 times x minus the x coordinate, 3/4. And now we just have a little bit of ugliness here. Again, fractional calculator's fine. Y equals negative 3/25 minus times minus plus. I don't ever miss that because I don't go to 3/25 times 3/4. I take care of signs. Minus times minus plus 9 on 100. And now I need to add 3/2. I need to add 3/2, but to get that as 100ths, I'm going to multiply by 50 over 50. 150 on 100, and I have y equals negative 3/25 plus 159 on 100. A little messy, but again, we can work calculators with that. All right, lines are parallel. Lines are parallel, as mentioned before, when slopes are equal. That should make some sense to us. Lines are perpendicular when slopes are opposite and reciprocal. So we're to determine if the lines are parallel, perpendicular, or neither. So let's find slope 1. Not a bad idea to use that notation. So slope 1, my y's go from negative 1 to 5, as my x's go from negative 2 to 1. And I get negative 6 on negative 3, or positive 2. Slope 2, my y's go from 3 to negative 5, as my x's go from 1 to 5, and I get positive 8 on negative 4, or negative 2. They certainly are not parallel. Are they perpendicular? No, they are not opposite reciprocals. They are just opposite. So this would be a neither. All right, equation of parallel and perpendicular lines in exercise 67 through 76, and we're going to need to write small again. Write the slope-intercept form of the equations of the lines through the given point that are parallel to this line. So parallel to that line, I'm going to steal some space over here. Parallel to this line, I need to solve for y. So I'm going to leave negative 2y. That would equal subtract 3x. Comes over and joins a positive 6. Divide negative 2, and I get y equals 3/2 x minus 3. So we want to be perpendicular and parallel and perpendicular, parallel to a slope of 3/2. So y minus the y coordinate, minus negative 1, equals parallel, same slope, 3/2 times x minus the x coordinate, 2/5. And let's see, right up slope-intercept form. Too bad, I wish it just said give me the equation of the line, but slope-intercept form. So that's y equals 3/2 x plus times minus minus. 2's reduce, 3/5, and I need to subtract 1. So minus 5/5. Y equals 3/2 x minus 8/5. And B, perpendicular. Well, it's the same. Y plus 1 equals an x minus 2/5 here, because that's our point. But the slope we need is opposite reciprocal of 3/2, so negative 2/3. So I get y equals negative 2/3 x. Nothing cancels. So minus times minus plus, 2 times 2, 4, 3 times 5, 15. And I need to subtract 1. So minus 15 on 15. And I end up with y equals negative 2/3 x plus and a minus, fight, 4 minus 15, 11, but the negatives win, so minus 11/15. Okay, and there is your assignment. And on your assignment, you'll note that this is common. I primarily assign the odd problems, and if 64 is in there, it probably means that I have some reason for taking a look at that one, so you focus in on it. All right, good luck, and let me know if I can help.